In Module 13, as part of our exploration of sex determination, I refreshed your memory on human reproductive anatomy. We covered basic anatomical terms and the fundamentals of spermatogenesis, how sperm develop and become part of the ejaculate. In this video, we'll dive into that process for females, what is called oogenesis. Since female reproductive anatomy not only produces gametes, the eggs, but also hosts the fertilized zygote and provides a safe place for its development over the next, ideally, 9 months if you are a human, well, there is a bit more to this story compared to what we learned about for spermatogenesis. And so, in this video, we will be talking about menstruation, oogenesis, ovulation, and conception. Remember, for men, sperm are constantly being generated in the testes and matured in the epididymis. This takes about 75 days in total. The process of spermatogenesis is thus a story of constantly creating new sperm. Good thing there is constant generation of new sperm, because the typical man will have anywhere from 40 million to 1.2 billion sperm cells in a single ejaculation. Making new sperm is the name of the game. So we had gone through all of these details. Now for women, the story is pretty different. All the egg cells that a woman will have in her lifetime are already present well before she is even born. A female fetus has 7 million primordial eggs, all that she will ever have in her lifetime. She has all of these 3 months before she is born. That's right. The eggs that will form her children actually start to develop when she is still in her mother's womb. Grandchildren literally begin in their grandmother's body. Because of this nesting of development, grandmother's life experiences influence how that egg cell develops. This is a type of biological inheritance, but it isn't genetic. It is what we call epigenetic. Remember when we talked about epigenetics back in an earlier module? What was that example? Can you remember? For a refresher, check out Module 7, Experience 3, when we talked about variation in adiposity. For the rest of a human female's life, she will spontaneously lose eggs at an exponential decrease through a process called atresia. She will have only about 1 million eggs when she is born, 500,000 at puberty, 250,000 by age 25, 16,000 at age 35. By the time she has just 100 to 200 eggs left, she will be entering the menopausal transition, when her reproductive phase of life comes to an end. This is usually around the age of 50. All of those primordial eggs reside inside the ovaries. There are 2 ovaries, one on either side of the body. They are anchored to the uterus by a ligament, and each ovary is about the size of a large almond. Let's look at one ovary up close. Here, you are looking at a diagram of a section through an ovary. Ignore the little tail of a sperm over to the left. I didn't completely remove it from the picture before I posted it. But here you're looking at a section through an ovary. You can see an artery and a vein entering the ovary from the ovarian ligament in the upper left corner of the ovary. There are 3 small brown dots, each surrounded by a white circle in the left part of the ovary, just below those blood vessels. These dots are the primordial eggs. In actuality, there would be about 125,000 of these in the ovary of a typical 25-year-old woman, not just 3. And it's 125,000 because remember, there's 2 ovaries. The white circle around the dots represents a capsule that houses the egg. This capsule is called the follicle. When that follicle breaks down, that is what we call atresia. Atresia can happen before maturation of the egg, which is what happens to most egg cells. However, once in a while, when a woman's body has a particular combination of hormones, this follicle will start to mature, and in the process, prepare the egg for ovulation. You can follow this schematically by moving counterclockwise from the 3 primordial eggs on the left, and the maturation process, it's not quick. In fact, it takes about 13 ovarian cycles to complete the process, so roughly a year. But then, once it is ready, the follicle will erupt through the wall of the ovary, releasing the egg. This eruption is called the Mittelschmerz, since some women who are very in tune with their bodies can actually feel this as a little popping sensation on one side or the other, and it alternates which ovary releases the egg in which cycle. So you don't usually have an egg released from both ovaries at the same time. They take turns. Now, we'll get to what that egg does in just a minute, but first, I want you to notice what happens to the follicle after the egg is released. Following the diagram counterclockwise, you see the follicle enlarges and changes, and it sticks around for about 2 weeks, continuing with its support of that egg cell. The follicle is actually releasing hormones that are essential to helping keep that egg alive and ready to be fertilized and implant in the uterus. Keep this in mind, as we'll visit this again in the next video when we talk more about hormones. But first, we'll finish our conversation about the anatomical changes before we go to hormones. Here, you can see a schematic of the ovarian cycle as a primordial egg is recruited. The follicle develops, erupts the egg from the ovary, and then forms a corpus luteum, then a corpus albicans, and ultimately it disintegrates as another primordial egg and its follicle are recruited. The process begins again. These events in the ovary are the core of the ovulatory cycle that sexually mature women experience during their reproductive time of life, from about age 13 to about age 50. This cycle within the ovary drives a host of other changes in the body. Let's add now a schematic of the wall of the uterus to our story. The formal anatomical name is the uterine endometrium, and this changes along with the ovarian cycle. As the follicle is developing, the endometrium builds up, and it becomes a nice blood-rich place for a fertilized egg to nestle into, if needed. But if a fertilized egg does not embed, the blood-rich lining sloughs off and is shed from the body through menstruation. So we have seen now that the ovulatory cycle, what it looks like within the ovary, and what it looks like in the ovary here, and what it looks like in the uterus. That moment of ovulation, when the egg is released from the ovary, it marks the midpoint of this cycle. The phase before ovulation is referred to as the follicular phase, as it is dominated by what the follicle is up to. The second phase is the luteal phase, as it is driven by the hormones released by the corpus luteum. So that follicle switches into being a corpus luteum after ovulation. Now, changes also happen to the cervix of the uterus. Remember when we talked about the immune system and how the innate part of the immune system creates barriers that protect the orifices in our bodies? The vagina and the cervix of the uterus are highly vulnerable entry points for bacteria, viruses, parasites. Over many millions and millions of years, a spectacular set of protective features have been selected for. These provide an amazing balance between protecting the body from foreign invasion, but yet also enabling sperm to enter so that fertilization can occur. Most of the time, the cervix rests low within the upper regions of the vagina, and it's closed tight, keeping the entry point into the uterus protected. And you can see that in this diagram here. This diagram shows 3 different stages of what the cervix is up to over the ovulatory cycle. First, it's firm, low, closed, and non-wed. However, just as the follicle is releasing the egg, there are a couple of days when the cervix loosens up, becomes soft, and opens up, enabling sperm to enter into the upper tract of the female reproductive system. And then it closes up again for protection. If you have a uterus, you can actually feel this change with your fingers if you want to check it out. There are some other things that also respond to these hormonal shifts. For example, the fluids that the vagina releases for protection. Vaginal secretions are fairly acidic, about the same as tomato juice in terms of their pH, and they are essential for keeping the body protected from infection. For the few days around ovulation, there is an increase in the amount of these secretions and in the consistency of them. They become more like egg whites, kind of sticky, and forming, like you could put them between your fingers and then pull your fingers apart, and you'll have this thread of the secretion between your fingers. This shift in the secretions facilitates sperm motility and health, and simultaneously has to not be too inviting to pathogens. It's a real delicate balance, and millions of years of evolution has led to a pretty remarkable balance. The microbiome of the vagina is also tied into the health of the reproductive tract, and its pH changes over the ovulatory cycle. This is why I strongly encourage women not to tinker with their vaginal secretions. Appreciate them, cherish them, and be thankful for the amazing things that the process of evolution has brought about. The things that your body is doing, millions and millions of years of evolution. In addition to the ovulation and the changes in the cervix and vaginal secretions, those signaling hormones do other things too, and one of them is to cause a slight rise in body temperature. Women who are ovulating can actually track their cycle by charting their temperature every day. You can use an app on your phone or chart it out by hand on a graph like the one you see here, with the days listed on the x-axis and temperature on the y-axis. Using a very sensitive thermometer and taking your temperature, if you're a woman, first thing in the morning before getting out of bed, an ovulating woman will have about 2 weeks of temperatures around 97.5 degrees Fahrenheit. And then, at the midpoint of their cycle, there will be a jump of almost 1 degree. Body temperature then stays elevated for about another 2 weeks. That quick rise in body temperature, it coincides with and results from the shift in hormones that cause ovulation and the subsequent hormonal support for that egg as it potentially implants, fertilized into the uterus. Women who pay close attention to their ovulatory cycle can actually use this knowledge to control their chances of pregnancy. For example, if you want to get pregnant, right when your temperature rises, that is a great time to have a romantic encounter with your partner. But if pregnancy isn't on your to-do list that month, you can avoid sex around the time of ovulation and instead enjoy those encounters a week before or a week after. Since sperm can survive in the female reproductive tract for up to about 5 days, and the egg is hanging out ready to be fertilized for about 2 to 3 days, if you want to reduce the chances that they meet up, be sure to keep that whole week around ovulation in mind. The ovulatory cycle sketched out here is 28 days long. So many sources will tell you that this is the typical length of an ovulatory cycle, and that ovulation happens on day 14. The truth of the matter is that, like all other things, there is variation. Only about 15% of women actually have a 28-day cycle. Everyone else who is healthy ranges somewhere between 24 to 36 days. What we have seen here is that human females ovulate on a regular cycle, regardless of whether or not they are having sexual intercourse. This is what we call spontaneous ovulation. We aren't the only animals that do this. All primates have spontaneous ovulation, as do hoofed animals like cows, also dolphins and elephants. Bears also have spontaneous ovulation, but they only do so once a year rather than monthly like humans. Many of these animals have very clear signals that they are ovulating, such as the sexual swellings of chimpanzees and baboons. Males of these species find these swellings quite irresistible. Farmers have long been paying attention to the behavioral signs that a cow is ovulating, and then they can make sure she is fertilized by the male of the farmer's choice. Controlling mating opportunities is key for animal domestication, and also for animals that have social organizations in which males compete for sexual access to females. Notice that humans do not have these sexual swellings, and it is thought that instead of advertising ovulation, instead, humans have evolved to conceal ovulation so that females are not advertising to males or to other females when they are actually in that fertile window, when they have ovulated and when they are capable of becoming pregnant. Now, not all animals have spontaneous ovulation, though. So, for example, most carnivores, rodents, insects, and tree shrews are induced to ovulate when they have sexual intercourse. They do this by having really short follicular phases. So house cats and lab mice, you put sexually mature males and females together and you'll likely get ovulation and an attempt at fertilization. What about menstruation? The shedding of the endometrium of the uterus at the end of the ovulatory cycle. This cyclical bleeding is a big part of a woman's life when she is in her reproductive years. You have to plan around it, you have to always be mindful of it, invest in supplies to deal with it, etc. Do all spontaneously ovulating animals bleed as part of their ovulatory cycle? The answer is no. Many monkeys and most ape species do bleed as part of their cycle, but they don't bleed as much as humans do. There is a lot of debate about why this might be, and from what I have read, the most likely reason stems from how the placenta attaches to the uterus. A richer uterine wall will facilitate a greater invasion of the placenta, and we think that human placentas do this to a degree that is greater than many other animals. There is still a lot of comparative research to be done in all of this, in placentation, so the formation of the placenta, in ovulatory cycles, and in my opinion, this is a really interesting and exciting area of biological science. We've talked about the ovulatory cycle and what happens when the egg is not fertilized. That is, generally speaking, pretty much what happens to most of a woman's eggs that make it to ovulation. They are shed through menstruation. However, sometimes the egg meets up with a sperm cell. Let's talk about that. In this figure, you can see the follicle that just released the egg cell. It is labeled with the number 1. At point number 2, some sperm cells have found it. Fertilization typically happens within the fallopian tubes, as you see here. The fertilized egg then starts to replicate. By 30 hours post-fertilization, there are 2 cells. 5 days post-fertilization, the embryo is a hollow ball that is about to figure out which end will be its head and which will be its anus. And this is when it first implants into the uterus. Once it implants, the embryo starts to produce a hormone called HCG, short for human chorionic gonadotropin. Only embryos produce this hormone, so if someone has HCG in their body, they have a growing early-stage embryo in their body. This is the hormone that pregnancy tests detect, and it is the hormone that starts the handoff of control over the woman's reproductive system from an ovulatory cycle to a pregnancy. HCG keeps the corpus luteum going longer than it would on its own. Remember how the corpus luteum emits hormones that keep the uterine lining in place? HCG induces it to keep going on with this job for a little while longer. Once the placenta has formed, and remember the placenta is an organ that the embryo makes. Once the placenta has formed, about 8 weeks into gestation, the embryo no longer needs the corpus luteum's help. And so it stops producing HCG and the corpus luteum's job is done. This is why pregnant women will sometimes post on their pregnancy blogs how they took another pregnancy test for the fun of it and got a negative result despite their huge bellies. Isn't that funny? Well, sort of, I suppose. But now you know biologically the explanation for that. One of the things that might have caught your attention here is how much happens really early on in a pregnancy. In fact, lots happens well before a woman would even be able to detect her pregnancy with a pregnancy test. She won't have enough HCG in her system until about a week after fertilization. And if she isn't anxiously taking pregnancy tests, she won't have the first indication of a pregnancy until the luteal phase of her ovulatory cycle doesn't end on its usual schedule. Since that corpus luteum is induced by the HCG to keep going, the uterine lining won't be shed, and she won't have her menses. This is usually when a woman has the first indication that she's pregnant, i.e., she misses her period. A professor in my PhD program studied human fertility and wrote a fantastic book about variation in human fertility across many different cultural groups. His research, which I'm going to talk a bit more about in subsequent videos, his research team did a study where they recruited women who didn't practice birth control to pee in a cup every day for many months. From all of these cups of pee, the scientists were able to use pregnancy tests to determine whether or not a woman had HCG in her body, i.e., if she was pregnant. Since the women wouldn't know for another week when their menses didn't come, the scientists got a good measure of how many fertilized embryos implant and produce HCG, but don't continue long enough to delay the woman's menses. It's about half. About half of all conceptions spontaneously abort before a woman even knows she's pregnant. Many other studies have found that of known pregnancies, about 15 to 20% end in miscarriage. This means that about 60% of all pregnancies don't make it. And this doesn't even include the ones that didn't make it to implantation. When you think of the complexity of meiosis, the complexity of development and embryogenesis, it's not surprising. So many things have to go right to form a viable embryo, and then a viable fetus. It is actually more amazing how many babies actually do make it to birth. The vast majority of them do not. One last thing before we move on. How often does fertilization actually occur? It is quite a journey for sperm and egg to meet. Is this something that happens easily and often, or is it the culmination of a Herculean effort? Data show that for a couple who are both in their early 20s and who have sex about every other day, there is about a 20% chance of getting pregnant each ovulatory cycle. Added up, that means that they have about an 85% chance of getting pregnant in a year. Just 85%. But as with everything, there is a big caveat to these numbers. That 20% chance of getting pregnant each cycle, it declines with age. Now this graph has age categories plotted on the x-axis, and the likelihood of getting pregnant in a year of regular sexual intercourse on the y-axis. Pay attention to the black line, as that is the likelihood of getting pregnant. The blue line is the likelihood of infertility, i.e., not getting pregnant. The likelihood of getting pregnant within a year is 86% on this chart for women in their early 20s. For women in their early 30s, that's 63%. And for women in their early 40s, it's 36%. There are always going to be stories of women in their 50s who get pregnant, but these are women who are really at the extreme end of a range of variation. For most women, the likelihood of getting pregnant at age 50 is virtually zero. And remember, for every woman who is able to get pregnant in her 50s, that means there are also women on the other side of that distribution who have trouble and are unable to get pregnant in their 20s. Now, this decline in fertility, this might be something that sounds scary, or perhaps it is something that sounds freeing. An older friend of mine who married in her 50s, she said that it was wonderful to be in a relationship with someone without having the issue of children, wanted or unwanted, even be in the conversation. And now we are at the end of this video. I'll see you next time when we start looking into the hormones that control all of this.